only, no zeros, means that there are branches that goes to infinity. Okay, rule number 5, is it? Okay. All right, that would be 60, 180, and 300. 3 angles to guide 3 branches. Okay. All right, so here the breakaway point, if you need me to stop and have, if you have question, please, yeah, please tell me. Yeah. All right, the breakaway is at, okay, you have two answers there, yes. Yeah, because you can see that you have this equation after the differentiation of the k equation over s. And then with that, you know that when you equate it to 0, you have two answers. Yeah, and the one that is yeah, possible to be the breakaway point should be, yeah, in between. Yeah, the pole just now is at 0, -4, and -6, so should be in between 0 and -4. Obviously it is the negative 1.57. That's correct. Good. Yeah. Okay, and then you can continue with the, okay, I don't have that. Oh yeah, I have. K equals to 240. Okay, Shelton, okay, get rid of that negative. Yeah, you take the positive number.
Okay.
How do you get negative?
Pinasa sebelah positif, negatif
Oh,
K.
louder, I cannot hear. Maybe your equation here.
Negatif
Can?
K.
Yeah? Hmm.
Kan ada negatif K sebelah kiri.
Formula macam mana? Formula is negative 1k tan 24. Yeah, over 10. So it means that it should be 240 minus k, right? 240 minus k. That should be it. Okay.
Okay.
All right. So go
Negatif
back
tak
to, huh?
darab semua ke madam? Dia tak
Yeah.
darab semua tu.
Okay. All right. So this should be 240. Okay. This is minus, right?
Plus.
Yes.
Okay.
Go back. Okay. K, no. Kalau you make plus here, this should be negative k. Okay. What's the formula? Remember? No. Go back to the formula. Okay. Now your equation is okay. All right. So if I draw back the table, yeah, S3, S2, S1. Okay. So you have correct me if I'm wrong, yeah. 1, and then you have 24. This is 10. This is k. Right? So you have to calculate here. Negative of that determinant, 1, 24, 10, k, isn't it? Okay. All right. Can you see clearly? Okay, so this is 0 already. Okay, taking that, your calculation would be, yeah, supposed to be k minus that, right? But since I have negative there, so I start with the other way around. 240 minus k equals to 0. Okay, so actually it should be negative k minus 240. Chilton,
Okay, madam.
get it? Yeah?
Yes, yes.
Okay, all right. Okay, let's move on. Okay, that's just minor. Yeah, okay, thing to correct. Okay, so here, all right. Okay, you are taking just above it, yeah, 10s squared plus k, you know the value. Okay, that's why you have a positive. That, okay, that is one of it. So you push it to the right side, it becomes negative. Yeah, negative divided by 10, negative 240 divided by 10, you get 24, and then you square root. Yeah, that 24, since you have negative, that's why you have j. Can you see what I mean? Okay, can you correct that? Yeah, so that is
Okay.
the that should be negative number, negative 24, and then you have to square root it. Yeah, that is why negative, if you square it, square root, yeah, becomes j, it gives you j, right?
Hmm. Okay.
Okay,
Faham, faham, faham.
clear. Okay, so
Clear,
your
clear.
answer is correct. Okay, okay, just mathematics there. All right, now very quick picture. Okay, I zoom out a bit. Okay, clear. That's important. 0 minus 4 minus 6. Three branches, yeah, should be there. You are right. 1, 2, 3. I can see that. And the breakaway point is negative 1.57 just now, isn't it? Yeah. Okay. So you can also label that. Yeah, negative 1.57. Okay, and the crossing there, yeah, because you have already do the refining calculation, yeah, using the rules, you can also label it with J, what's the number? Okay, 4.9. Okay, nice, 4.9. Okay, just below the J5. All right, thank you. Yeah, that's correct answer. Okay, I want to move to the next one if there is no question. Okay, let's have a look at some of your friends on Gila. Yeah, several other answers here. Okay. Um, okay, B ada. B. Okay, I think this is B. Yeah. Okay. All right. A we done already with Shilton's answer. Yeah. Okay, this is B. Okay, let me zoom in. Okay. Now the question is asking about whether the point given to you, yeah, the point given in the question is the closed loop system for the system given with the open loop transfer function, yeah, GS there. Alright, so you just put it on the graph like this, yes, yeah, and then 0 minus 4 minus 5 are the only open loop poles that you have, yeah, for the from the system. Put it there, sketch all the vectors towards it, start calculating the angles. All right, now let me check the angle. Yeah. Okay, so you have 11656, that's correct. For theta p1, that's correct. Okay, good. 63 for the p2, theta p2 63.43, that's right. Theta p3 is 53.13. Okay, summing them all together. Okay, so here, Nabila, are you here, Nabila? Can you hear me?
Yeah, medium.
Good. Nabila, you are not finished yet. Now, answer dah correct dah. Yeah, but the finishing, yeah, is not there yet. Yeah, so that's correct equation to use. Yeah, you are checking whether the summation of the total Z minus total P is it equals to the odd multiplication of 180 or not, right? Isn't it? Yes. Okay. Now
Okay.
theta Z is nothing. Yeah, no Z, right? Okay, but the
Yes.
theta P, you have negative there. Can you see negative there? Okay, let me zoom a bit. Negative, right? So you should have negative in bracket, everything
Um,
else. Okay, so your answer
okay.
becomes negative 233.13, which
Mm,
not equals to the odd multiplication 2k plus 180, remember? Okay, put it there. Yeah, not equal to. Okay, therefore, make the conclusion. Because the question asks you, you see, justify is a big word. Okay, so it needs to come with explanation. Why you are saying that this is not the closed loop pole? Why? Okay, you found out that it is not the closed loop of the closed loop pole of the system because of this reason. It doesn't comply the angle criterion rule, right? The angle criterion property, the locus property. Okay, and therefore make the conclusion. Okay. Okay, finish. B. Any question? Okay, clear, very clear sketching there. Thank you very much. Okay, any question regarding the tutorial 1B? Okay, I can see that your friend here has tried 1C. Okay, let me have a look at the answers. uh-huh. This is B. Okay, this is B. Okay, let's look at C. Okay, quite a longer answer, isn't it? Yeah. Okay, so here let's check. Okay, the answers. Okay, first of all, the question is asking you to sketch. Okay, sketch, and then the second part of the question is asking you to um, also, yeah, check whether the system can perform with the requirement about the settling time and also the percentage overshoot. This information gives you the dominant pole. Yeah, dominant pole, yeah, the desired closed loop pole for the system to have. So you need to check whether system can perform with the only K, because you can see from the block diagram, the only compensator that is given to you for the system, yeah, is only K. So it is clear that this is about root locus. Okay, with the simplest form of capacitor, which is the K. All right, so so you can use the property, yeah, to check your the point, required point, whether it's on the root locus or not. Okay, so I think that that is answered in the second part of the the tutorial answer here by your friend here, Winston. Okay, now let's have a look at the sketching. Yeah, all right. Now, first thing first, you list down all the poles, yeah, the zeros from the open loop transfer function. This is important because when you don't write it, yeah, because yeah, you can tend, yeah, you can possibly make mistakes. Okay, plus minus there, yeah, you separate them, yeah, because when you count for the asymptote, yeah, later, yeah, that would be that will give you the correct number. Okay, so here -5, -3, yeah, plus j2, -3, minus j2, yeah, that's correct for the open loop pole. No zeros there, yes, yeah, look at the block diagram there. They are, it is third order, isn't it? Yeah, third order system. Okay, so that is the equation that to be used, yeah, when you start using the rules, yeah. Okay, very small. Yeah, wait, I want to. Okay. Right. Okay. Now let's move on. Okay. If I'm too fast, you can tell me. Yeah, so that I can repeat back. Yeah, whichever that you probably miss out. Okay. Sent the asymptote is -3.67. That's correct answer. Okay. See. Yeah. When you have your points correctly, yeah, you have correct points, you can calculate yeah, the asymptote also correctly. Okay, so this is very important. Yeah, divide by 3, yeah, not by 2. And then your angles, okay, why you need asymptotes? Because there are only 3 open loop poles, right? You know that 3 branches would go towards infinity, so that's why you need the asymptotes. Okay. So 60, 180 and 300 is your answer. Okay. Okay, you should add another one. Okay, Winston, yeah, add another one. 60, 180 and 300. Okay, you should have 3. All right, now next. The breakaway point. Okay. Okay, hold on. What do you have here? Before you continue with the breakaway point, okay, try and sketch the system, yeah, root locus using the 5 basic rules. 5 basic rules. What happened? Okay, put all the points, the OLP, inside, yeah, onto your S plane. Okay, don't you have the sketch? Maybe not yet. Yeah, not yet finished. Okay, so actually these steps, yeah, for the breakaway, yeah, it is questionable. Yeah, you can question. Okay, you need or not? You can question yourself. Yeah. Okay, let me see whether it's in the part 2. Yeah. There you are. Okay. All right. Now, when you sketch using the 5 basic rules, then you can see. Okay, 1, 2, 3. Okay, 3 means that you have to draw the asymptote lines. Okay, you have the asymptotes already. That is at -3.67. Is it clear? Somewhere there, yeah. You mark the point there. Okay, don't put cross, yeah, but you just put a dot. Yeah, okay, a dot. Okay, and then start drawing the asymptote line. Okay, so the first one is 60 degree, isn't it? 60 degree. The next is 180 straight line on the real axis, and then the next one is 300, 300 degree. Okay, so you should have three lines on the sketch, and then you use it to draw your um, the branches of the root locus. Clear, Wistin?
Yes.
Yeah, okay, draw. Okay, 5 basic row first and draw. Okay, next towards the three additional. What is that? The break in point, the crossing at the j omega, and also the angle of departure or angle of arrival. Okay, so from this basic, the 5 basic rows, right? First row, three branches. Second row, it need to be symmetrical. Yeah, about the red axis. What is third? Third is left, right? Left, right, left, right. Okay, so on the real axis, yes, you are sketching the root locus correctly. Okay, Winston, can you put an arrow there? Yeah, to show that this is root locus towards the left side. Okay, the arrow also shows rule number 4. It's the destination. Okay, it will exit from the opposite pole and then finding your infinite zero. Okay, same goes to the complex conjugate poles. Yeah, okay, you can also show arrow there. Yeah, all right, next asymptote is the fifth one. Yeah, yes, you need it because there are three that needs to go to the infinity. That's why you have to draw on the S-plane. Okay, so drawing the asymptote, yeah, would show how you understand to use it. Yeah, to sketch the root locus. Okay, all right. Next is the sixth rule, is it? Yeah, do you need to calculate the breakaway or breaking point?
No.
Why?
Complex.
Again?
Ada complex?
Mm. Is there any pose that have break out or break in? Pose or
No.
zeros that have break in on the real axis? No. Yeah?
No.
Okay? Because these two, okay, these two, you know you that you have, okay, after you sketch your asymptote, you know that your pose will be guided towards that point, that line. Okay, you can draw it, yeah, so you know that it will be guided towards that line. That's why it's important to draw the asymptote. Okay, so towards finding what? Finding zero. Because why? There's no zero, other zero, whether it's on the complex conjugate part or the on the real axis. No, so it needs to go somewhere else, infinite zero. Okay, okay, same to this the last pole. Yeah, if you have a zero there, then it's finished. Yeah, on the real axis. Okay, all right. In fact, it is on the real axis. Yeah, you know that it's heading towards the left side and forever. Okay, towards the infinity. All right. Okay, so in another case, if you have a pair of zero or 1 0 on the real axis, okay, maybe like for instance somewhere here, probably that two will go in. Okay, oh, hold on. If you have one, okay, one, look at this one, it will go straight away to the zero here. Can you see? If you have pole there, if you have 1 0, okay, use rule number 3. Left, right. You see? So there would be okay, ways, yeah, to decide whether which pole would go to which zero based on the rules. Okay, there will be many kind of situation, right? Okay, but you don't have to worry. You just use the rule one by one. Okay, number three is important for the poles or zeros on the real axis. So you can decide, okay, whether this one goes to left or right. Okay, all right.
Okay,
Okay,
madam.
any question about that? Okay, I think that we are not finished yet. Yeah, we have to look at the crossing. Yeah, crossing. Oh, okay. So big. Okay, here, all right. Um, is that the correct answer? Okay, let's have, okay. I think you're missing with 65 there. Am I right, Kristen? Yeah. There should be s cubed plus 11 s squared plus 43 s plus 65 plus k. Okay, you're missing with the 65. I think that the earlier page, you have 65 there. Do you know what I mean, Christian? Okay, 65 is there. But when you transfer your answer to the second page, okay, you have missed out the 65. Okay, so if you put in the 65, your answer will be different. Okay, for those who have answered this already, can you tell me what's the answer for K? Guys, I know that some of you have done this. Yeah, can you tell us? Yeah, what's the answer for the K that you have together with the point of crossing? Anybody? No.
Negative 22.
Negative?
22.
No, that's not right. Okay, let me have a look at. It should be 408 there. Oh, there are new answers. Okay, thank you.
Saya pun salah, madam.
Salah juga.
Ah,
Shelter
lupa,
salah juga ke? Berapa you? K equals to berapa?
lupa juga 65 tu, madam.
Lupa juga. Okay. I'll check another one. Okay, Nabila ada ke?
Nabila
Okay,
tak
you
buat.
need to put. Tak buat apa? Sini.
Uh-uh.
Sini. Okay, siapa buat ni? Okay, try to fix your answer. Try and fix your answer. Now, Wisten, Shilton, yeah, try. What do you get? You can quickly calculate that back. Yeah, so your table should be okay. If I write it down, oh, the neck ni very slow. Okay, okay. If I put it in table, yeah. Okay, maybe some of you try the direct substitution. Okay, all right, do that. Yeah, you will get same answer. Don't worry. Okay, whichever that you like, it's okay because it's just optional. Yeah, I mean things that you can select. Okay. You have S2, S1. Oh, good. S. Okay. So you from the equation, this is 1, this is 43, this, oh, okay, okay. Um, 11, right? Okay, 11, and this is, okay, be careful, this one is together because they are with the S to 0, yeah, S to the power of 0, no S. It means that they are called the constants, yeah. Okay, so here negative the formula 1, 11, 43, 65 plus, okay, langgar dinding lah. Okay, so this is 0. Okay, so
For 08, madam.
okay, what do you get? Oh yes, that's your answer.
Okay.
Yeah, that's the answer. Okay, so your answer would be um, k equals to 408. That's right. And then calculate your PS for the point of the point, the crossing point. So you're taking the upper part here, 11 s squared plus 65 plus k. Okay, equate it to 0. This is PS. Yeah, the even polynomial. Okay, you know the k, you put in, you get your s. Okay. So what do you get for the j? J point 6.56 something, right? Okay. So once you're done with that, you put back in your where is your answer? Okay, put back in your sketching. Yeah. Okay, put it back. Okay, so that is j plus j 6.56 something there. Okay, and then the, yeah, that is actually the k that is responsible to bring your system to have the closed loop pole to be at that point j.56, yeah, is k equals to 408. All right, so yeah, that is understanding. Yeah, okay, you know that that is something to do with the range of stability. Okay, remember, yeah, your the block diagram, where is the location of k? K is just in front of your plant, yeah, as the compensator, yeah, the simplest form. It's like the controller, gain adjustment. Okay, but there is another thing that you have to calculate, right? Yes, down there. Yeah, angle criterion, the last angle of departure. Sorry, angle of departure. Yeah, because this is root locus departing, yeah, from the open loophole. Okay, you have to calculate the departure angle. All right, so here we just have to use the uh, angle criterion, yeah, equation. Okay, drawing all the vectors, yeah, from the other open loopholes towards that departing, yeah, root locus, which is from the that open loophole. Right, you will have theta 3, obviously that's 90 degree because they are conjugate pairs, yeah. So theta 3 90, theta 2 it's here. Okay, okay, why so late? Okay, theta 2. Okay, so here, yeah, you have to calculate correctly what's the value there. Hmm. Okay, I need the point first. Minus 3, that's minus 3, that's d2. Okay, minus 5 minus 3, so 5 minus 3 is 2. Wisden, Wisden, what's this? Where do you get this? Okay, can you calculate back? The difference between here and here is 2, right? Okay, so that is 2 by 2. 2 divided by 2. Okay, so you have 45 degree there, right? And then summing all back, yeah, to get your theta d or theta 1 here, departing angle. That should give you, okay, 180 minus 45 minus 90. Okay, all right. So what's the answer?
45.
Yes, that's right. Yeah. Okay, 45 degree is your answer. Or minus 315 will also, yeah, if anybody of you, yeah, got minus 315 because if you change the k value, yeah, 2k plus 180, okay, you will get negative 315, which is same, yeah, mathematically is the same value, or equivalent to 45 degree. Yeah, you don't have to worry. Right, finish with that. Any question? You comfortable
Meja
now?
lagi.
Yeah.
Boleh explain yang angle 1B tadi tu?
Angle 1B, 1B,
Ya,
tutorial 1B.
ya, ya.
Okay,
Ya.
okay. Hold on. With actually C, the C, you are not finished yet with the question, right? Is there any other answer? Okay, remember the bold part? The question in bold part, yeah, is asking to check, yeah, whether the system can perform with the performance with the requirement or not. Okay, that one is not there yet. Okay, I will find other answer for you, yeah, for 1C second part. Okay, now Shilton is asking about the B, the angle. Okay, so this is not complete. Okay, let me look at Shilton answer for B. Yeah,
Pun tak complete madam.
tak complete juga. Siapa tadi saya tengok? I think Nabila, is it? Are you comfortable with this discussion?
No.
No? Why? Tell me why.
Confusing.
Why? Which part that you want me to adjust? We actually
Mm,
have covered almost three questions already, right? Okay, so that is, yeah, that comes from your effort to answer. That's your commitment as student. Okay, so are you comfortable with using the Google Classroom?
oh,
If no, tell me
ya,
why.
ya, ya. Boleh, boleh, boleh.
Boleh? Tell
Boleh,
me
boleh.
why. Which part that you want me to, I mean, probably I can adjust, yeah, and work on that. Yeah, you tell me, yeah, because you are the one who's listening, yeah, my voice from over there. Okay, so maybe I need, yeah, a suggestion from you if you want it differently. Yeah. Okay. Okay, about this question, you talk about the angles just now. Okay. All right, so what's the question, Shilton?
Yang pasal equation madam cakap tadi.
Equation
Ah,
which one? The angle criterion.
ah,
Angle criterion is this. Okay.
yang
All right. Angle criteria, right? Okay, I will use my sketching here. Okay. All right. Okay. Right. Okay, make it a bit smaller so that I can show you back your friend's answer there. Okay, all right, now how many angles, yeah, how many or open loopholes or any zero? You have only three. Can you see that from the question, from the transfer function? Yeah, you have 0, -4, -5 only, right? Okay, all right, now, okay, okay. Okay, so 0, -4, -6. Now, towards that point, the point of interest, the point that you need to check because that is asked in the question, right? So you just draw the vectors towards that point. Okay, so this exercise we have made, we have um, um, we have done, yeah, this exercise in at the beginning of root locus. Okay, where you are given with 2 points to check. Okay, now this point you are not yet, yeah, confirm whether this point is on the root because that's the question, right? So to check whether it is belongs to the system or it is on the root locus, you have to use the angle criterion equation. Okay, so here, right, so what's the formula? Okay, you cannot forget about this formula. Yeah, we have used this so many times and it's very easy to remember. Okay, you can imagine that kgh having the upper part, having the bottom part. The upper part of kgh having the zeros, the bottom part is about the poles. Okay, you're talking about zeros and poles here. You can talk about this when you're looking at points on the root locus. Okay, yeah, without any point to refer, you cannot take this. You cannot think of these vector lines. Do you understand what I mean? When you look at this equation, how that it gives me the angle of 0 and the angles of poles, because you're talking about any point on the root locus would satisfy this equation, okay, which must equals to 2k plus 1 times 180, or the odd multiplication of 180. Okay, you only get this one when you talk about, when you are referring to, or you are talking about a point on the locus. Okay, now this point is, you don't know yet. Yeah, you have not confirmed it yet whether it's on the locus or not. Okay, so to confirm it, use this angle criterion, put the angles of the vector lines towards the point of interest. Okay, so theta 1, theta p1. Okay, so 0 is nothing. Okay, so here you have theta p1, theta p2, theta p3 that your friend has calculated correctly. Okay, all right. Okay, so what's the answer from there? That is the answer, isn't it? With negative. Am I right, Shelton? Can you get it?
Yes,
Got
can.
it?
Okay.
Okay. Yeah. Okay, because you have negative there. Okay, so inside here you have 116.56 plus 63.43. Apa lagi? What else do you have? Oh, there. Already there. 53. Yeah? 53.13. Okay, put them all inside there. You'll get your answer as minus 233.13. And is that equals to this or not? Easily we can make judgment, right? Okay, it is definitely not. Yeah, so if it is not, now this is the criterion. Does the point, yeah, does the point the closed loop pole of the system or not? And you should answer it using the angle criterion. Okay,
Okay, madam.
boleh.
Boleh.
Any question, any part that probably you need more explanation?
Dah.
Tak ada. Okay, this is direct, right? Okay, normally you have to pick the key, isn't it? Yeah, but this one no need to. Yeah, because you are just trying to find, yeah, this one, this part, okay, this solution, whether it's equals to the this part or not. You're just confirming. Okay, you are not like when you did your design, yeah, last class, you want to find the theta PC or theta ZC. That's different, right? Same equation, but you have unknowns. Okay, you have the theta PC unknown, or both theta ZC or theta PC unknown. Yeah, so in that case, yeah, to solve the unknowns, you have to set the k, the small k, not the big k. Okay, the small k to a value, because you need a value, okay, from the right side. Okay, so that's different. Okay, but this question is another thing different. Okay, try and understand the question. Okay, all right, now it's 9 o'clock. Probably that you need a break, yeah, but I wish that I have somebody who has answered, yeah, the second part of tutorial 1C. Do I have any volunteer? Can you tell me? There are only 5 there. Yeah, maybe inside that 5, these 5 friends of, yeah, friends of yours who have submitted answers. Yeah, probably I can show you the tutorial 1C part 2. Anybody?
Belum juga.
Tak ada. Si Nabila, have you answered tutorial 1C completely?
No.
No, not yet. Okay, what about Mike?
Belum, madam.
Belum juga. Ya ke? Okay, so it's easy, not difficult. During the break, you can try and do that. Yeah, because you are given with a percentage overshoot, 1.5%. From there, you calculate zeta. Okay, from the what else? TS, you are given with a value there, 1 second. Yeah, that gives you the sigma d. Okay, so Mike, yeah, Mike have tried 1A, yeah, and also probably 1B. All right, so I'm giving you 10 minutes enough, yeah? Okay, I think, oh, that is C. Mike has tried C, yeah. Okay, so that part is also like Christian, yeah. You have to fix that, yeah, because the gap there is just 2. 2 by over 2 is 1. Then tangent of 1 is 45 degree, yeah. Okay, so finish that part 2, yeah. Okay, so you will get I think I just give you the point. Okay, to confirm, do that. Do this by yourself. Minus 4 plus J3. Yeah, minus 4 plus minus, no, dominant pole. Minus 4 plus J3. Okay, minus 4 plus J3 with the decimal. Yeah, you find it by yourself if you have decimals. Okay,
Kita
and
tadi tu.
yeah, again.
Saya ada buat. Sekejap.
Tak
Saya
ada buat.
akan.
Nabila ada buat kau?
Sekejap. Tapi saya tak
Hmm.
letak lagi dalam tu. Saya bagi kat WhatsApp madam boleh?
Ya, ya ke?
Sekejap.
Cuba submit je. Nabila banyak buat ni. Ya, 2 pun ada. Okay, nanti after the break, okay, we'll start the design question. Okay? Alright. So I hope that I think that several others have done something. Mesti punya. Takkan tak buat apa-apa ni. Alpha, are you there?
Yes, madam.
Takkan tak buat apa-apa.
Ada, saya dah buat tapi tak submit lagi.
Kenapa tak submit? Okay, please submit now, everybody. I want to just have a look at it. Yeah, I want to see your effort. Next week is your test ni. Yeah, I don't think that you don't do anything. Okay, you must do something. Yeah, at least 1A. It's tiada punya. Okay, so I'm hoping to look for more. Yeah, like on the design question, for instance. Yeah, okay, please. Yeah, okay, jadi for this 1C, okay, I think let's finish with the sketching. Huh? Um, all right, let's move on to the design after the break. Okay, so for the, mari kita tengok Nabila dah hantar belum? Okay, by looking at discussing your own answer, okay, I hope that you will get more confident. Okay, memang if I check on your answer, if you write your own answer, your own understanding there, okay, you get the confident more. Don't worry if you get it wrong, it's okay. The wrong part is important to discuss why it's wrong. Okay, all right, so that will start the discussion back about the concept. Right, don't have to worry about that. Yeah. Okay, if I just give you the answers, what for? It's not me, who's taking the test of the final. Okay, I'm your tutor, right? So you are the one who must be the main actor or actress, for the class. All right, so here 1B, 1C is not yet. Maybe I have to refresh. Nabila, have you uploaded? Is it D here? Maybe. Switch off the video, okay? Alright, battery is running out. I have to switch off my video. Is it okay? Okay, we can still talk. Alright, what happened? Okay, is that... No, that is different question. Calculate demonstrated function. 1D. Let me check. Okay, I have answers there. For that point, oh my god. Oh, D. Oh, dah ada C. Okay, thank you, Nabila. Okay, alright. Okay, very good. GC, quite fast. Okay, itu dia. Conteng pun conteng lah. It's okay. I don't mind. Yeah, Nabila. Okay, as long as I can see your answers there. Yeah. But of course, yeah, test ke final cantik lah kan. This one is for exercise. Okay. Okay, Zita. Let me check. Zita is 0.8. Yes, that's correct. Very good. And then using the okay, you are using the theta there. Okay, and then you use the, is it tangent? What is that? Zeta omega n. Okay. Okay, you calculate the omega n. Okay, omega n. All right, you're using the equation. All right, yes. So -4 plus j is like 3, right? Okay, so that's the answer. Good job. Yeah. Okay, now it's just checking whether, okay, all right. So done with the point. The question is asking whether the system can perform with this TS and percentage overshoot. It means that from the requirement, it gives you this point. Okay, so it means that now, in other words, the question is asking whether the system can have this point as part of the system, as part of the as one of the closed loop pool, closed loop pool for any k value, right? So that is the other meaning of the question, right? So it means that you just have to check whether whether that point is the closed loop pole of the system by using the angle criterion. Okay, so you just use like the tutorial 1B just now, the same thing. Yeah, total theta z minus total theta p, whether it is equals to 2k plus 180 or not. Okay, and okay, the answer is no. Okay, but what's the value? Yeah, you have to check. Okay, just like B. Yeah, it's easy. All right, and make sure that you answer the question. Okay, saying that yeah, that is not the system cannot perform. Yeah, because of what is it? Okay. All right. Now it's 9:11. Any question about the second part of tutorial C?
No, madam.
Clear, yeah? Yeah?
Clear.
Okay, good. So root locus and the root locus property, then okay, let's move on to the design. Okay, but I think let's have a break. Okay, let's have a break. Just 5 minutes, can we? Yeah, 9:18. Yeah, we'll come back. Yeah, we should continue. Okay, time is really running. Yeah, very fast. Okay, so I have 2A there. Okay, for those who have submitted, now 6 already. Who have submitted 7 dah ada. So see, mana boleh tak buat apa-apa. Mesti buat punya. Kan? Alright, so mesti ada apa-apa. Those especially, those who have write something, yeah, tried tutorial 2. Okay, please upload so that we can discuss afterwards. Okay, dah 9:13 dah. Let's have a break. Ada bunyi Shopee coins tadi. So, mau shopping ke, Mike?
Shopee je madam.
Shopee, eh?